Good morning friends and dear student. It gives me immense pleasure to be here again for my favorite course, Flight Mechanics. As of now, I am running with the topic cruise flight. I have already completed my initial phase, that is introduction to atmosphere, different layers of atmosphere, basic lift theory, drag polar, induced drag, parasite drag, drag reduction techniques, L by D maximum, V minimum drag, maximum velocity, stall velocity, condition for highest range, endurance, different types of ranges. These all things I have already covered. Today I am going to take a very important topic of effect of altitude on airplane performance. So we have seen in the previous that the density matters. Every equation you will see lift half rho v square. Rho is there means density there. Wherever density is there, it depends upon the altitude. As you go higher and higher, altitude is reducing. So this altitude will also affect the performance of engine as well as the aerodynamic performance, that is the wing and all. They will also be affected by the altitude. So there is a propulsion issues because your engine thrust will be reduced. So this power. So this I will be covering in this introduction to ceiling, types of aircraft ceiling, cruising altitude of Boeing 747, variation of flight cost with respect to the altitude, and effect of altitude on performance. So I will just discuss about altitude, and we have seen, if you see, just you see here, this is the thrust versus velocity curve, and if you see here, this is our thrust required TR, and the another one I will just give. This is the thrust available. This is in the sea level condition. As you go up and up, and this is thrust available is produced by the engine. As you go up, the density is reducing, the suction capacity, the mass of the air which is entering inside the engine is reduced. So as you go higher altitude, this is at sea level. I am writing 0 here. But as you go up, it will go like this. Your TA will be reducing like this. So TA1, TA2, TA3. But what will happen to this TR curve? TR curve, I will draw it here again by the same color. This at another altitude at 1, this will be TR1. Then this will be TR2. One condition will come that this is equal here. One condition will come where you won't get any additional thrust. So as you go higher and higher and higher, the excess power excess thrust which aircraft supposed to have will be negligible, and you cannot fly beyond that. That is the height or the altitude when you won't get any rate of climb. The rate of climb is 0. Means there is a thrust required and the thrust available. Both are equal. Aircraft will go like this and it cannot climb like this. It will be there only. So that is the altitude which is called the absolute altitude. All aircrafts are designed for certain height and their performance will be accordingly. In this lecture today, I am going to discuss about this altitude, and we will see that different types of altitude, and this altitude are called the ceiling. Means up to what height this aircraft can fly. That is the meaning of this altitude. So just I will go ahead with this. So what is the ceiling? Ceiling is defined as the highest altitude at which an aircraft can safely have a straight and line level flight. Means this is the highest altitude which aircraft can go. And why? Just now I have explained. As and when the thrust available or the power available is equal to the thrust required or the power available. This thrust required and the power required is nothing but a drag. Your aircraft is having lot of drag. As and when you go up and up, this drag will also increase and the available power will reduce due to the density effect. And so one situation will come when thrust required and power required, thrust required and the thrust available both are equal. That altitude is called the ceiling. So the highest altitude that an aircraft can reach by its own engine and have sustained flight. So that is called the ceiling. The higher the ceiling, the better is the aircraft performance. If you see the fighter aircraft, they can go very high altitude. But if you see the passenger aircraft or the general aviation aircraft, small Cessna and all, they will not go so much altitude. Altitude is also very important parameter. If you see the cases F-16 and some other aircraft or mix and all, F-16 has got more altitude. So it can attack from there to the mix and other aircrafts. Because attacking from high to low is very easy. But from low to high, due to the gravity or missiles and other things, it will go less speed. But if you attack from top to bottom, it will be very easy. That is why F series, they have more ceiling and they are better aircraft. Very significant for the military airplane, these parameters. If the ceiling of a fighter is higher than the ceiling of the missile in a specific region, this fighter can operate freely on that region and survive. If you know that the enemy country knows that whatever other country has the missile, it can go up a certain height. So they will fly their aircraft above that height. So you cannot hit the aircraft and they will hit and go. So it is very important parameter. The aircraft parameters that positively influence its ceiling are the lower weight, higher engine thrust and the lower drag. So if your weight of the aircraft is less, it can go high altitude. If the engine has got more power, it can go high altitude. And if the drag is less, it can go high altitude. This regards to a Soviet MiG-25 that could fly 1,23,523 feet in 1987. In 1987, MiG-25 could achieve this altitude. As of now, I am not aware how much we can get it. Okay, so this is the introduction. Now I will discuss about the types of ceiling. In general, there are 5 types of ceiling. First is the absolute ceiling, that is HAC. It is denoted as a HAC. As the name implies, absolute ceiling is the absolute maximum altitude that an aircraft can ever maintain level flight. In other words, the absolute ceiling is the altitude at which the rate of climb is 0. Just now I have explained in detail. So the aircraft is not able to climb higher than the absolute ceiling. The absolute ceiling is sometimes referred to as the maximum operating altitude, that is MOA. This is also called the MOA. Okay, so this further I will discuss. Next very important is service ceiling. H means height, AC means absolute ceiling. Here H means height, SC means service ceiling. So service ceiling, HSC. Service ceiling is defined as the highest altitude at which the aircraft can climb with a rate of 100 feet per minute, that is 0.5 meter per second. So if the aircraft can go for certain height, and in that height the rate of climb is 100 feet per minute or 0.5 meter per second, that height we say that it is a service ceiling height or the service ceiling altitude, and this service ceiling altitude is less than the absolute ceiling. Next very important is a cruise ceiling, HCC. Cruise ceiling is defined as the highest altitude at which the aircraft can climb with the rate of 300 feet per minute, that is 1.5 meter per second. Cruise ceiling is lower than the service ceiling. So in the absolute ceiling it is 0 rate of climb. For the service ceiling it is 0.5 meter per second. For the cruise ceiling it is 1.5 meter per second. So these are the three. We have some more ceilings, that is combat ceiling. It is also HCC. Combat ceiling for the fighter aircrafts. Combat ceiling is defined as the highest altitude at which a fighter can climb with a rate of 500 feet per minute, that is 2.5 meter per second. Combat ceiling is lower than the cruise ceiling. This ceiling is defined only for the fighter aircraft. So this combat ceiling is only defined for the fighter aircraft. And MOA. MOA is maximum operating altitude. So this the altitude for which operation is allowed as limited by flight structural, power plant, functional or equipment characteristics. For instance, at the angle of attack, at the MOA, that is the operating altitude, maximum operating altitude, the pressurized cabin and the compartment must be able to provide a cabin pressure altitude of not more than 8,000 feet. So if you are going, this is the operating especially for the passenger aircraft like Boeing and Airbus. That time we should be able to maintain inside our cabin where passengers and the pilots air crews are there, the equivalent of 8,000 feet altitude, the pressure and the oxygen level has to be maintained. So these are the 5 altitude. We can see here absolute ceiling, then service ceiling, then cruise ceiling, combat ceiling and MOA. These are the 5 different types of ceiling which are very important to know all the aviators, aeronautical and aerospace people. This I am going to depict here some important ceiling height, absolute ceiling, service ceiling and the cruise ceiling. Service ceiling is about 90% of the absolute ceiling and the cruise ceiling is about 80% of the absolute ceiling. So everywhere it is reducing by here 10% and here also it is 10%. So the absolute ceiling, it is the highest ceiling where you can maintain the level flight, cruise and the level flight, where rate of climb is 0. Next is the service ceiling. Service ceiling is the altitude at which aircraft maintains the rate of climb at 100 feet per minute or 0.5 meter per second rate of climb. That altitude is called the service ceiling. Another is for the cruise condition. In this, the altitude at which the aircraft maintains 1.5 meter per second or 300 feet per minute rate of climb, that altitude is called the cruise ceiling. and here is the sea level. From here, all these heights are measured from the sea level. Cruising altitude of Boeing 747. So if you see here, here is the altitude and here is the weight of the aircraft. So effect of the weight on the aircraft. If you have the more weight here, less weight, 500, 550, 800, 1000, and this is the altitude. So if you have the more weight, assume you have the weight of 750,000 pound here. If you have this much weight, your altitude will be only this much. You can fly at a lower altitude. But if you have the less weight, 500, you can fly up to this altitude. So this is for the weight and the altitude effect. 40,000 feet you can fly if you have 500,000 pound. As your weight is increasing, your altitude will also decrease. So this we have to take care of. During flight, the pilot is calculating all these values. Then only how many passengers are there, what is the amount of fuel, all things pilot is calculating. Then only it is selecting the required altitude where it will achieve maximum CL by CD, maximum range and endurance it can achieve. The flight will be economical, fuel cost will be reduced. Variation of flight cost with respect to the altitude. So if you see here, if you fly at this is the cost factor here, and this is the point where you have the minimum cost. This is the minimum flight cost or most economical flight condition. Okay, so this is the condition where you have the minimum flight cost. So if you go above this altitude, and this is the altitude, so in this altitude you will have the minimum cost. If you go above that also, here, your cost will be increasing. And if you go lower also, at very low altitude also, your flight cost will be high. So pilot will select, this is the best altitude for each aircraft, depend upon the weight, of the aircraft. So this we have to take care of, and we have to choose accordingly this point in such a way that, and every pilot, when you go for any passenger aircraft, and pilot will announce that we are at 33,000 feet, 34,000 feet, 35,000 feet. Why he is announcing? Because in that altitude, the fuel consumption will be less, CL by CD will be maximum, it will reach early. So these all conditions are favorable, pilot will select that height. And this is calculated by the help of the computer. Computer will give the signal and it will give the values at what altitude you have to fly. For the autopilot also, it will give the exact values and accordingly your aircraft will fly. Now, two jet transport aircraft at their cruising altitude. So you can see here, Boeing 787 Dreamliner. This is the Boeing aircraft at cruising altitude. Antonov AN225 Mriya. This is another aircraft. They have some certain amount of altitude. In that altitude, this aircraft will always fly. In this altitude, they will get a most flight conditions. It is this example, a reference Now, effect of altitude on performance. So, we will see that how the performance of the aircraft is varying and how it is in kilometer, 9 to 13 kilometer. If you see in feet, it is 31,000, 33,000, 35,000, 37,000, 39,000 and 41,000 weight of the aircraft. Weight is very important. At what weight you are flying. So, this is the SAR in nautical miles per kg. This is your fuel consumption, and if you are flying at in this or in this and in this is the best zone which every pilot will try to fly, because every time this is not possible because there will be some wind condition, there will be some other aircraft. So in this, if you see this, and this is the altitude here, if you see here it is 37, somewhere 37,000 to 3,400, but maximum we fly here 35,000 here. Mostly they will fly here. So this is depend upon the weight. If the weight is less, they can go higher altitude. They can fly somewhere here, here and here. If the weight is more, they will fly here, here and here. So if from here to here it is 1% here more. Okay, so here also it is like that. So like this, the altitude plays very important role for the fuel consumption, and the performance of the aircraft is depend upon the altitude, and this is also the function of the weight of the aircraft. As you have the more weight, you have to fly the less altitude. Effect of gross weight on the cruise performance. So you can see here that we have here speed in knots and power required, that is the drag in horsepower. So if you see, if you have the lower weight, this plot, you need least power. If you have the medium weight and its speed is this, if you have the medium weight, this is shifting towards the right. If you have the higher weight, further this thing. And if you have here power available, you see it is very less, it is very much, and this is too much. So as per the given engine power, your L by D ratio is very important. For L by D ratio maximum, weight versus cruise flight. So this is the plot, and you can see as your weight is increasing, power required is also increasing, and it is huge amount of increases there at L by D ratio maximum. So that we have to take care of. Next lecture we are going to take some numerical 1, finding the coefficient of lift, then numerical 2, finding the time, that is the endurance, numerical 3, finding the velocity of the aircraft, number 4, finding the aspect ratio of the aircraft, number 5, finding the thrust to weight ratio. This we will be discussing in our next lecture. I have the references from Anderson JD, Junior, Aircraft Performance and Design, International Edition, McGraw-Hill's, First Edition, 1999. SL by ME, Aircraft Performance, Theory and Practice, AIA Education Series. YD Dwivedhi @gmail.com. This is my mail. You can mail me if any queries are there, any mistakes are there. You are welcome to mail me. You can also write the comments on the comment box. Please do like and subscribe this channel. Till then, goodbye and thank you.
Like, share and subscribe. Hit the bell icon for more updates.